Yeah, he hasn't been too bad, but sometimes he just gets into these like maniac puppy phases where he's a little monster.
Starts chewing on everything, probably.
Yeah, and he's just like if you take his toys away, he like barks at you, and but sometimes he's really cuddly, so he doesn't like to chew on his toys unless you're sitting next to him, and so he's crying right now because he wants me to sit next to him.
They're so fun.
Yeah. Okie dokie. Part 2. A lot of the stuff that we did this section was just knowing how to do it in SPSS is what it seems like.
Yeah.
Yeah, and I start to do it, and then I think, yeah, I get those mixed up a little bit. So if we just walk through it, I'm sure I'll get it figured out. So.
Okay, so when a professors at BYU Math Department collects data from BYU Idaho students to compare the mean wages of BYU Idaho males to BYU Idaho females, the students from his class completed a survey which he then used to analyze if there is a difference in these wages. Use class survey data to complete the problem. So we got to open up that in SPSS. Okay, so what is the research problem?
Is there a difference between male and female wages?
Right.
So, for the null hypothesis, would it be that they're the same?
Yeah,
Yeah.
you 2.
Yeah, so it'll be null will be equals the same, and then alternative will be U1 does not equal U2.
Right.
That's always for independent samples.
Okay.
Okay, decide the collection procedure. He asks them to fill out a survey.
See how much they make.
Yeah. Describe the data in a short paragraph. Use summary statistics to describe the data. After the paragraph, insert an appropriate well-labeled graph to illustrate the data.
Okay, this is where I get confused.
Okay.
So you go to the transform right here. Is that right?
Actually, for this one, you don't need to do that yet. You only
Okay.
transform when you need to do a compare means. So for this one, you go to descriptive statistics, and then you can do explore, and then you'll click. Oh, there's a lot of stuff in here.
To go.
We're looking for we're looking for their wage, right? Because that's what we're comparing. So wage goes into your dependent list.
Okay, where's wage? Okay, wage.
And then gender goes into your factor list.
Okay.
And then, yeah, you should be able to get a comparison that'll say male, female wage. Yep.
Okay. Oh, nice.
Yep. Okay. So let's see.
Yeah, I always thought I had to do the other one first, so I was like super confused. But the only time you do the transform is when what?
When you wanted to get a t-score. So when you're trying to go into compare means independent sample t-test, then you need to use the transform.
Okay.
So, so the means, did you get the mean for males is 11.93, 5, and then the females is 9.759.
Yes.
Yep.
And standard deviation for females is 3.16. If you got the mean right, it should have the same standard deviation.
Females is 91, and the N for males is 85.
Uh-huh.
Okay.
And then You can also do the same thing with, like, if you want to graph it. I think you just do your histogram, wage, and then I forget how to do the histogram. What goes into?
Well, I know you can do it on the analyzed descriptive statistics, what we just barely did, and you can just put plots and do a histogram right there. But where do you do it so you can see them right by each other?
Right, that's what I'm trying to think of. I don't remember. I remember it talking about it, but I don't remember exactly.
Is it you just go to graph legacy logs? I think that's how you do it. And then you go.
In your rows, I think you put your group.
So what would you put at the variable? Wages?
Yeah. So
And then
variables, wages, and then I think your rows are
would be gender.
gender. Yeah.
And then that should give us like a side-by-side one.
Yeah,
Oh, yeah.
I think so. Yeah, I'm pretty sure. Yeah, there's male and then female. Yep. Okay. So.
Okay, wait. So can we say that one more time? Sorry.
Yeah.
Okay, so.
The variable is what?
So the variable is your wage.
Okay.
And then you'll put in your rows.
Gender.
Gender.
Yeah.
And that's it.
Yeah.
Okay. Thank you. Got it.
Okay. What type of hypothesis test is appropriate?
Independent samples.
So it's a, two-tailed independent.
Two means independent sample.
Yeah. Okay. Are the requirements met for this test? Yes, because they are normally distributed, but they're, well, I guess we can make a Q plot to make sure.
Well, we have N1 of 91 and 85, though.
Right, and the other thing is, though, is they weren't simply randomly selected because they were a survey. But they said that if the QQ plot comes out that it's pretty close to normally distributed, then should be fine.
So we can, when we do descriptive statistics right off the bat, we should just do plots with histogram and QQ plots right there, right?
Yeah. The only
Then we'll
thing
know.
is, I don't know how to get separate QQ plots though.
Oh yeah, that's true.
Let's see. It made them separate. By just doing it that way, it made them separate when you divided it up. But they don't look normal.
It doesn't look normal. But I think they say that it's relatively close.
Okay.
So it actually, it really isn't, because it's not simple random, so the requirements aren't really met, but I think you're supposed to still go forward.
Correct, yeah.
Okay. Complete the test statistics. So this is where we have to do that transform stuff.
Okay, so now we go to transform.
Compute variable.
So for this, we don't have to do like the recode thing, like.
Yeah,
That's
this
what we're
one.
doing.
Yeah.
Oh, we do have to recode it?
That's what we're doing right. To get the test statistic is when we use the recode, right?
Yes.
Yeah.
Okay. So do we do
the
target
recode,
variable?
which is wage, right?
Okay.
Or wait, is it? I think it might be gender you put there. 1 second. Let me look again.
Okay.
Yeah, you actually put gender there. Sorry.
So you just type in gender right there?
No, you click on gender and then push it over. If that makes sense.
You put it over where it says variable and
New
like
name.
arrow new name.
Yeah, that's where you're putting it at. And then your new name should be group code or gender code. It said always use the word code.
So, okay, so we're going to go, I was on the wrong one. So we're going gender, and then new name is gender recode.
Yep.
And then add new name.
Yeah.
Variable name duplicates an existing variable. Maybe I already did this. Oh, I already actually did this a second ago.
Okay. So now we should have another one. And now, if they're male or if they're female, they're 1, and if they're male, they're 2. So then we'll go into analyze general means independent sample t-test. We'll put in wage, and then we'll put in as our grouping variable gender code.
Okay, we're going independent sample t, right?
Yep.
And so we're going test variable is wage.
Yep. And then your group variable is gender code.
And then you define the groups as 1 and 2?
Yep, 1 and 2.
Okay.
Okay, so now we have t value, and we have confidence intervals, and we're supposed to use equal variances not assumed, so the bottom row.
Oh, yeah.
In which case, I got a t value of 1.836.
I got negative.
Okay, wait a minute. Is this for the male or female?
This is actually, the t value for them is actually grouped together.
Oh.
Interestingly enough.
That's
So
how
what
it always is?
Yeah, so what the test statistic here is doing is it's comparing the two of them together, and then it's computing a test statistic to determine if there is a significant difference for your probability and everything.
Mm-hmm.
It does it together?
It does, yeah. I was really confused on that too.
Yeah, I didn't get to that part of the lesson, I guess, not yet.
Yeah, so it'll give you their means and their standard deviations
right,
separately.
And the group
right.
statistics, right?
Right, but for this, the way the SPSS computes this is it's doing all of that computing together.
Okay.
So but you always want to use
degrees,
variances not assumed.
Okay, so are the degrees of freedom the 98.263?
Yes.
So,
and then is your t-value a negative one, right? Negative
yes.
1.
The thing that they said though in this lesson, and in most cases, you always have to assume your t-value is positive and negative.
Okay.
Okay, because it's both sided.
Yeah.
You got negative 1.836.
Yeah. Because they will always be, with an independent sample, it will always be a two-tailed test.
Oh, okay.
Okay.
So it's both.
Yeah.
Okay.
And so then, did you guys get negative 1.836?
Yeah.
Okay.
Yeah.
In this case, then, you compute the p-value and compare it. So the p-value is the same thing. It's that they're put together. So it's, in this case, 0.9.
Let me call you right back.
0.
Yes.
What did you say?
0.69.
Oh, okay. Yeah, I see that.
And then we're going to compare it to our level of significance, which is 0.05. And we'll make our decision, which in this case, it is higher. So we would fail to reject.
Fail to reject.
Okay.
In this case, there's not sufficient evidence that wages are different. Okay, rather than testing a hypothesis, now you say you just want to estimate the difference between female wages at the 95% confidence interval. Create a confidence interval that will estimate this difference.
Okay. So do we already have it right here?
Yeah, we already do. I think we already have it. But I don't know. Let's see. The lower would be... So this is where it's confusing me because they're saying the opposite of what we're saying on here for their confidence intervals.
I know. I think that when I've seen that before too, and they're saying it just depends on where it's double-sided like that. It could be either one. You can do it negative 4.528 and then or positive 4.528 and then negative of the other or positive. It's
the same.
Yeah, I've seen it where like it come up I came up with it backwards, and they're like, it just depends on what you have in there first. But I don't know.
Okay.
I
That's
don't
probably
know if
true.
that's real.
That probably is true.
So we still would use the negative 4.52.
Yeah, I think if I was putting it in a quiz, that's what I'd put.
And then 0.176. Is that what it says on the answer sheet?
In the answer, it's opposite. It says it's negative 0.17622 and then 4.52858.
But that could have been. Do you think that could have been because they did like females was group 2 and males was group 1? Like.
Yeah, absolutely. So
Yeah.
does it matter? I mean, I
Well,
don't know.
I don't know either.
Because all we're looking at is if the zero is within the confidence interval.
I don't even know how you would change females to group 2.
Would you just put, like, instead of putting 1, 2 on the groups, you would put 2, 1?
2, 1.
Yeah.
Yeah. Let's see what that does.
Yeah. I think that's the way you would change it. But again, I don't know how much that matters because really the only thing we're using the confidence interval for is to see if 0 is in the confidence interval.
Right.
And it is. So I don't know if it would matter which one was there. So
I can't get mine to redo my independent sample t-test.
oh.
Yeah.
Well, yours? Oh, I got it. Never mind.
Did it work?
Okay, 2 versus 1. We get all the same stuff. Yeah, it is actually.
Yeah. You put the 2 first instead of the 1 first, and then it.
Yeah, and then it put negative 0.762. Yeah, it's just the opposite.
I bet like on the quiz though, like it would mark
It would give
right.
you credit for either.
Yeah.
Nice.
Okay, now interpret the confidence interval you built above.
It's because 0 is in the
Oh, it's a
confidence
0. Yeah, you're not supposed to have a 0.
Because the 0 is in the confidence level, then you have insufficient evidence.
Yeah. Yeah, I remember them talking about that.
Mm-hmm.
Take action. They need to find. I don't know, what action can they do?
Like, know that. I mean, this. I don't know.
Yeah, they just learn whatever.
Whatever.
Yeah. Okay, cool. Let's take the quiz. True. Okay. Everybody in?
Yep.
Yeah.
What requirement must be checked when concluding hypothesis tests comparing two means with independent samples?
Random
Simple
sample
and what should we do?
sample mean. So A and B.
A and B. The test statistic for hypothesis tests with two means with independent samples is t-score.
T-score.
Two samples are independent if knowing which subjects will be in group 1 tells you nothing. I think it tells you nothing. Yep.
Yeah.
Use the data file dentist office bills. Okay. Where's dentist office bills?
Let's see.
Okay, I've got it up.
Mine's coming. Oh gosh, I just went out of everything. Okay.
Okay. It says, what is the degrees of freedom? Okay, so that one you have to get. Let's do analyze and then descriptive statistics.
Descriptive
Get
and
our
explorer.
explorer. Yeah, get that out.
Okay. We're trying to find out what again? What does it say?
Which we're trying to find the degrees of freedom, but that won't tell us this in
Samples of
this.
dental bills. Samples of dental bills.
Yeah.
So.
Dental bills is your
Is
dependent
the
and then
dependent.
factorless. Yeah.
Do we put anything for the factor?
I don't.
Yeah, I think you do. You put city.
Is it asking us that?
Yeah. So the city is Idaho Falls and Rexburg, but
oh yeah, Idaho Falls and Rexburg. Yep, it is asking us that. Okay.
in order to get the standard, or in order to get the degrees of freedom, though, we have to do the coding first. But I just wanted us to get the actual descriptive statistics first, so that we didn't mess it up when we decoded it. So yeah, do an automatic recode, and it would be
Once
the
we
variable.
have that, we'll automatic recode it.
Yeah, and recode city.
Transform, automatic recode. Variable is city.
Yeah, city code.
New name is city recode.
Yeah.
Add new name. Okay.
Okay, so now we have Rexburg and Idaho Falls in 1s and 2s.
So we go to analyze, compare means.
Yep.
Independent T. Then the test variable is the bill.
Yep. And then your group variable is city code.
City recode.
And then 1 and 2.
1 and 2.
Oh.
That gives us the degrees of freedom.
Is when we put in, or where do we type in like group 1 and 2? How do we do that for that?
Right after.
Define groups, yeah.
Where is that? Is that when we're still doing the automatic recode?
No, that's in t-test.
Oh yeah, okay.
So the degrees of freedom is the bottom one.
Yeah, 37.996.
96.
Did you get that, Mackenzie?
Okay. Well, I got a little behind because I couldn't find the independent samples, but now I found it.
Okay.
So for the test variables.
That's gonna be your bills.
Okay.
And then your next one, I don't know what it is, what it's called. I think it's defined variables or something.
Yeah. Okay. I got it.
That's where you put your group code.
And then you just did group 1 is 1 and group 2 is 2?
Yeah.
Yeah, which is good.
Okay, I got it.
So did you get 37.996 for your degrees of freedom?
Yeah.
Yep.
Okay. What is the standard deviation for Rexburg? Well, we've already done this, so we can just scroll up and find our standard deviation at the top.
So 288.60.
I actually got for Rexburg.
Oh, that's the mean. That's the mean. Standard deviation.
2.06.637.
So not 2 point, but 206.3. No, 637. 206.637.
206. Okay. What is the test statistic? So that's our t-score.
We already got the t-score, right?
Yeah. So it would be negative 0.434.
Okay, where is that at? Oh, 434.
Yeah, at the bottom. And the p-value. Okay, I lost my place too. The p-value is 0.666.
Yeah. Okay.
Okay. So we're using a level of significance of 0.8. 0.10.
Okay, slow down for 1 second. You guys are too speedy sometimes. 0.666. Okay,
Yeah.
got it. Okay.
And so our alpha is 0.10. So this
What
is
does it say
much.
that up at the top?
Yeah. It says A alpha equals
Yep.
0.10.
I got it.
So then I think we fail to reject.
Because it's too high.
Yeah.
Okay.
Okay, suppose your alternative hypothesis is... Oh, wait, is this a two-tailed test? Oh, it is a two-tailed test.
It's a two-tailed test, so we got to divide that.
Yeah.
So we divide the 0.666 by 2?
Yeah. It's still too high.
Yeah, it's 333. Okay.
So we still failed to reject. So then times that by 2, which is what we got. We still failed to reject.
Okay. Wait, so number 9 is 0.333 instead of 0.666?
Yes.
Okay.
Okay, now we have to do it again with data file freshman dinner. What was the data file called?
Freshman dinner.
Freshman dinner.
Freshman dinner. Okay. Okay.
Okay.
So we'll do Explorer again first, just to get it out of the way.
Okay.
So we go, what are we trying to find out again? So we go freshman and then state is the factor? I didn't look at what it said.
Yeah, freshman dinner and then state is the factor.
Freshman dinner times freshman students from Utah and Colorado. So. And then state is the factor. Plots.
And then do the automatic recode stuff.
So we'll have it all up.
Yeah,
Okay.
it's going to ask us questions off of those, so.
So transform automatic. So again, we go freshman is the variable or state?
No, if you're doing an automatic recode, state is the variable.
State, because we want to try to define the states.
Right.
State. Because that's really the only one that we can divide. We can't divide freshmen. We can only divide the states. Okay.
Mm-hmm.
So when we put the test or the independent sample test for the test variable, that's the code, right?
Yes. Or no, test variable is freshman, and then the grouping variable is code.
Oh, okay.
So now we go back into analyze, compare means, independent. Test variable is freshman. Freshman?
Yep.
Grouping code is the new one we just made.
Uh-huh. And then define it as 1 and 2.
2.
Okay.
Okay, so we should have everything now.
Yep, so we should be able to just go get it. Okay.
Mm-hmm.
What is the appropriate alternative hypothesis?
So it says the data represents the number of times freshman students from Utah and Colorado cook their own dinner in a month. You suspect that freshmen from Utah cook dinners for themselves a different number of times than freshmen.
Oh, it's different? It means it should be equals with a line through it.
Right.
Because it's not bigger, less.
Okay. So then Then it's asking us what the test statistic is.
So that'd be negative 0.845.
Yep.
Then it wants to know the p-value, which is, because it's a two-tailed test, 0.410, I think. Is that what you guys got?
Okay, just a second. I typed that in wrong, so I guess.
Wait, but for the last one, I thought we divided it in half.
We did, because it was a one-tailed test, because it had a greater than or equal sign.
But this one's 2.
This one's a two-tailed test.
Okay, so it's asking for the p-value, and it's 0.410.
Yeah.
Yeah. Yeah.
0.410.
And do we fail to reject it?
Yeah, so we failed to reject again.
Because it's too high. Was that one what was the level of significance? 0.05?
Yeah, 0.05.
Okay.
Okay, so then the lower limit.
Okay, back up for 1 second. Were any of the ones that we did up higher negative numbers of our answers?
Yeah.
Yeah, the t-value.
Which one?
Number 8.
8 was negative? Dang, I didn't put negative in front of it. Ugh, okay.
I think like technically speaking, it is positive as well.
Oh, that's true. We talked about that, huh?
Yeah. Okay.
Okay, so sorry. So now we're on 16.
Yeah.
95% confidence interval. We already have that, right?
So
Yeah.
negative 5.137.
Yes.
And
2.204.
Yeah. Okay.
I think that should be right. If it's not right, I wasn't understanding something.
Negative 5.137 and sorry. 2.204.
Mm-hmm.
Okay, so some of these negative and positive could probably be either way when we're doing double-sided.
It should be, yes, it should. So it should be right either way, but we'll see.
Are you guys submitting?
Yeah.
Okay. Yay! 100%.
100.
Nice.
Yep, we got it. Yeah, this one was, I felt like this lesson was just, if you can figure out what to do in SPSS and what numbers they're looking for, then it's pretty easy.
Right. Yeah.
And like I said, since I didn't get all the way through, I got confused on the analyze, but that helped a lot when you guys, the transform, but that helped. Trying to decide what group to put where is still medium clear. I just have to look over it again, but it makes sense because usually there's only one thing that can get divided.
Right.
Yeah, that's true.
So.
Good job, guys. I'll post a video.
Job.
Yep.
Yay.
See ya.
See you later.
Bye.